All right, and now that we have seen how to change a vector's magnitude by any value, we call that a scalar, we will learn how to change a vector's magnitude to a very specific value of 1. We call that a unit vector. That's the remainder of the lesson. You remember when we did the unit circle, that came out of having hypotenuse lengths that varied for special triangles, and we wanted to have a standard length. We made it 1. Same idea here with a vector. Now, a unit vector is a vector that is exactly 1 unit long, and we find the unit vector by taking the magnitude and dividing it into each of the components, which is what this little formula shows. The V with the arrow over the top shows each of the components when it's written in component form, and then the bottom is just going to be a magnitude that we divide by. So to create a unit vector, divide a vector by its magnitude or overall length. And let's look at a fairly straightforward one. In this case, vector A is 5 units long. It has a length of 4 units in the I direction and 3 in the J direction. But if we don't want to deal with a 5, we want to deal with a 1 as a standard length, we need to convert all those ratios down to a similar triangle. The hypotenuse of the red triangle is the unit vector, which goes in the direction of the green vector. All right. So if we look at this vector A, we see it written as 4i plus 3j. And another way to think of it is we take 5 times the cosine of the angle to get the horizontal and 5 times the sine of the angle to get the vertical. And that comes from some of the trig we've done here this semester. But to unitize it or make it 1 unit long overall, we simply divide by the magnitude, or 5. And in this case, it would be 4/5 I plus 3/5 J. And we can find that information. We'll show you in later problems. So let's just basically look at this problem and say, find the unit vector 4, 3i plus 4j. So we just did this problem basically, but let's take a look at it as a new problem. We want the unit vector. It's going to come from the vector divided by its magnitude. The vector is 3i plus 4j. The magnitude is, if we looked at this vector, right 3 and up 4, it would be square root of 3 squared plus 4 squared. That's 25, which of course is 5. And writing a fraction, we can put 3/5 as the component for the horizontal and 4/5 for the component of the vertical. Now, since we have a unit vector, we can take the vector that goes 3i plus 4j, broken back, it is now a unit vector of 3/5 I plus 4/5 j. And if we want a value of 10 for that magnitude, 1 is a nice number to work with. 10 times 1 will give us a total length of 10. So we could just distribute the 10 times 3/5 I plus 4/5 j. And doing some quick kind of simplifying or reducing, we would get 2 times 3 is 6i plus 4j. All right. Now you might have noticed, this is a good calculation, but really you might have noticed that this graph essentially, or sorry, this vector essentially is doubled. To go from 5 to 10, should have allowed us to just double. But sometimes numbers don't work out that nicely, for instance, for this problem. So why don't you take a moment, see if you can get the unit vector, and then from there, create a vector that is in the same direction as vector v, but a total of 7 units long. So go ahead and hit pause. All right. Well, unit vector v will be the vector 5i minus 2j divided by its magnitude, which is the square root of 25 plus 4, that's 29. And if I split that up, I get 5 over root 29i minus 2 over root 29j, but of course we don't like that form. We got to rationalize. So we get 5 root 29 over 29 plus 2 root 29, sorry, not plus. J. Right, so there's our unit vector. To make a vector in the same direction 7 units long, we simply take 7 times the unit vector. And that's 35 root 29 over 29i. Okay, not real complicated, but that's how we do it. On your own, see if you can create the scalar multiples of these values as well as finding the unit vectors. We'll see you in class.